Hey students, welcome back. Today we're going to do chapter 13.4, which is nonlinear inequalities and systems of nonlinear inequalities. We've done some inequalities before. The nice thing about these guys is that we're just going to graph them. We don't have to solve them. We just graph them and visually look at the solution. Because we have inequalities and not equal signs, we're gonna shade an entire region of the graph to represent all the points that are solutions to that inequality. Okay, let's take a look. All right, so 13.4, graphing nonlinear inequalities and systems of inequalities. So when we graph nonlinear inequalities, we first are going to graph the related equation. This is just our equation with an equal sign instead of an inequality. Then we're going to test a point in every region that's created by that equation. We test a point by plugging it into our original inequality. If it makes our original inequality true, then we're going to shade that region. Then we go and make sure to make a dotted line where the equation was graphed if we have a strictly less than or greater than sign. And that will symbolize that the points on that line aren't actually solutions to the inequality. We'll put a solid line where our equation was if we have a less than or equal or a greater than or equal sign, because that means points on that line are solutions to our inequality. Okay. So let's do this example. 16y squared is greater than 9x squared plus 144. First step we'll do is graph that related equation. So our related equation, 16y squared equals 9x squared plus 144. Looking at this, since the x is squared and the y is squared, we know we either have a circle, an ellipse, or a hyperbola. We don't know which one exactly, so all three of them in their standard forms have the x and y on the same side. So to get that on the same side, we'll subtract 9x squared from both sides. And then we'll see we have a hyperbola. And we know we want to set a hyperbola equal to 1. Subtracting 9x squared from both sides, we'll divide by 144. And then we'll get this equation. Y squared over 9 minus x squared over 16 equals 1. Okay. And then we graph that related equation. So the graph of that equation looks like this. The way we came up with it is we drew our box. So our radius in the y direction is 3. Our radius in the x direction is 4. So we basically drew a box that's 3 away from the center in the y direction and 4 away from the center in the x direction. Once you draw that box, then you put lines through the corners of the box to guide your asymptotes. So that guides these asymptotes there. And we know it opens up because y is first and x is being subtracted. So from the very top of our box, we just create our hyperbola using the box as a guide. I didn't draw the box here because I used a software to generate this graph, but I am going to make another video that's going to do a bunch of graphing by hand. All right. So that's the graph of our related equation. Now we're going to test a point in every region. You actually get to pick what points you want to test. You get to pick what points you want to test. We're going to pick some easy points. Let's pick 0, 5 in this top region. Let's pick 0, 0 in this middle region. And let's pick 0, negative 5 in this bottom region. You can really pick any point in each region, but I like to pick these because x is 0, which means that's one less number you're going to have to calculate. So for our top region, 0, 5, we plug in to our original inequality that x is 0, y is 5. And we see if it makes it true. It says that 400 is greater than 144. That's true. So this region would get shaded because it is, any point in this region makes this inequality true. Our next region is the middle with 0, 0. And we find that that says that 0 is greater than 0, which is not true. 0 equals 0. It is not greater than 0. So that region is false, and we will not shade anything in that region. No points in this region are solutions to our inequality. For our third region, 0, 5, we get that 400 is greater than 144, which is true. So that is also a solution. So our top region and our bottom regions are solutions. So we shade them. And then we check, do we need a dotted line or a solid line? Since we have a strictly greater than, and this equation is where the two sides are equal. When the two sides are equal, it is not strictly greater than, so it is a dotted line. We are not including the points on the line. So this is the graph of this nonlinear inequality. It shows all the points, so this entire area, every point in this area are solutions to this inequality. And all the points in this area are solutions to this inequality. Okay. If you want, you can pick some points and check for yourself that any point up here makes this true. Any point in here makes it false. Okay. Take some time to work through those steps. Maybe pause the video here and work through that on your own. If you're still having trouble graphing, maybe go back and practice your graphing a little bit. Let's go on to the next example, which is systems of nonlinear inequalities. So a system of nonlinear inequalities is the same thing as before. It's a system of equations, which means that we now have two equations. So now its solutions are where both of these equations are true. But the process is the same. We just have to do it twice and then overlay those two to find everything that makes both of those equations true. We start with one of them and we go through the same process for this equation. The related equation for y is less than x squared is y equals x squared, and it looks like this parabola. Then we'll test some points. Let's test a point above the parabola in this region. I think the easiest point to test is 0, 1. Now let's test a point below the parabola in this region. You could pick negative 1, 0, 1, 0, 0, negative 1. These are all good picks. I just picked negative 2, 0 because it shows up nicely on this graph. You just have to pick one point in each region. Okay. For the upper region, 0, negative 1, we find that it's false. It's false that when that 1 is less than 0. So we know that none of the points in this region satisfy this inequality. For our second region, the lower region, negative 2, 0, we find that that's true. That satisfies this inequality, which means all the points in that region below our graph satisfy that inequality. So we can shade that region, and then we're going to check to see, do we make a dotted line or a solid line? Since this is a strictly less than, it means when x equals y squared, the points on this line, they're not included in this inequality. So we make it a dotted line. All right, so that's step one. We just graph the one of our equations. Step two, graph the other equation. Our other equation, our related equation is y equals negative x plus 2. So that's this straight line going through 0, 2, and 2, 0. We do the same process. We'll check 2 points. I think the easiest points here are 0, 0 for the lower region, 0, 3 for the upper region. And notice the regions I'm talking about are the regions created by this graph. So this is what's dividing up our surface here, and so I need something on both sides of that line, right? For 0, 0, we get that it makes our original inequality true, okay? For 0, 3, we find that that makes our original inequality false. So we shade in our graphs accordingly. Now this is a less than or equal to, this equation, this inequality is less than or equal to, so that means XY pairs that make the y equal to negative x plus 2 are still solutions of this inequality. So we are going to include the points on this line, and so to indicate that, we make a solid line here. Right? So our first graph shows all the points that satisfy this inequality. Our second graph shows all the points that satisfy this inequality. Now, what a system of inequalities is asking for is all the points that satisfy both of these. Not just one or the other, but both. So that's the area where these two graphs overlap, right? So what you can do is you could have graphed these on the same axis at first. If you've got colored pencils or something like that, you can do that. But sometimes it's nice to graph them separately and then combine them. This is what it'll look like if those graphs are combined. See how I overlaid the two graphs, and shaded in purple is where both of them have solutions. So it's this area shaded in purple that is actually the solution to the system, okay? This area right here is not a solution to the system since it only solves the first equation and not the second equation. This area over here, same thing. It solves the second equation, but not the first. This area up here doesn't solve either of them. So it's just that purple area that is the graph, which is the solution to the system of inequalities. Okay, let's recap what we did, and then I'll show you another graph of the solution. We went through the process for one inequality, went through the process for the other inequality. Then we combined the two to see where they overlap. It's going to look like this. So here, the actual region that is the solution to the entire system, I shaded in black. So that's where both the red and the blue graphs are true. Notice here, we've got a solid line there because points on this line make both of these inequalities true. Okay. This line here, though, is dotted because points on this line do not make these inequalities true. Do not make both of them true, okay? And then this line back over here is again solid. So that's that the dotted part is curved, the straight part is solid. If we go back, you'll see the dotted line was the curved one, the straight line was the solid one. So our region here, it's dotted, or sorry, it's solid, dotted, solid. And so that's what we've got, all this region in black. Any point in black here will solve both of these inequalities. All right, so that's two examples, solving inequalities and solving systems of inequalities. It's just a graph. That graph shows the solution. So if you're asked to do that, you just graph it and shade the area that is the solution area. All right. Take some time, go back through these slides. They're very dense, and I will post a video tomorrow that shows graphing all of this stuff from chapter 13. Good luck with everything. I hope everything's going well for you guys. Send me an email if you need help. I can do a Zoom session. I can respond to your emails with pictures. Let me know what you need, and good luck with everything. See you next week.